Okay, the distance angle method. The setup here uses the true angle, the new true angle 2. That's the angle component of the method. That's our most precise method, allow you to work in urban areas, tight areas where the compass is going to be affected. We've also got the TruePulse 200i up here as well. Going to measure distance and angle for you. And then we're showing a Trimble DA2 receiver here with this setup as well. And then we're running the Field Maps software and the Connect app as well. So to start the point for distance angle, I'm going to go ahead and start a point here and then offset its location. That's going to start up the Connect app because we chose that in the profile section. So the first time around, I'm going to need to connect to the laser and the true angle. I'll also connect to GPS at this time. And I'm going to use location services. As I mentioned before, you feed the GPS signal to location services on the Android device, and then the apps will use that information, both Field Maps and Connect here. So I've got that started and I'm ready to go. I'll choose distance angle method. You'll see values for antenna height, instrument height, and target height. You want to get those measured in. It'll give you a good accurate ground elevation for all your points. So the antenna height would then measure up to the bottom of the antenna, and then the laser right to the reference point on the laser. And record those values in the app and you're ready to go. What we're doing here at this post is we're going to log this as our backside point. And then we're going to move over to where the feature is and take our shot out to it. So the backside point, we're maybe 50 yards, 50 meters away from it here. We're simulating using RTK. You can be nice and close with your backside point here. If you're using a GPS that's 1 to 2 foot or worse accuracy, you want your backside to be farther away, 100 meters or more. Get a longer baseline on there. It's going to give you a better reference azimuth to use. So we'll go ahead and log this point here. I'm going to use the base. It's tilted. I'll be able to see that base there. All right, that's done, and we're ready to move up to the station where we're going to measure to the feature. So we've moved over to our station now where we're going to set up. We've got a good view of the feature out in the roadway and a good view of the backside point. So now we can log our location here and save that point, and then it generates the reference azimuth back to the backside point. Now what we'll do is go ahead and just aim at that backside point with the encoder and zero it there. So now we just spin over and shoot at the feature. And you can see the distance, angle, inclinations all recorded there and the offset coordinates. So then we tap save and the point comes right back into Field Maps.